Okay, so let's have a problem on how to get the average acceleration using our knowledge in calculus. So let's say we have a velocity function. Let's say the velocity function is v sub x is equal to 3.0 plus 0.1 t squared. So this is our acceleration function. Now, if we are to get this is our velocity function. So if we are to get the acceleration function, we need to use calculus. So from velocity to acceleration, we will use differential calculus. We will differentiate to get ax. We know that ax is equal to dvx all over dt. The differential of the velocity with respect to time over dt. When we say d, it is the change. So this is just your delta vx over delta t. Remember, this is also our equation for average acceleration. This is our equation for average acceleration. Okay, so if we will apply now differentiation to our velocity function, we will now have the differential of this function with respect to time. Function is 3.0 plus 0.1 t squared. So our acceleration function now will be, wait, let's just distribute the differentiation so that we can simplify the dt of 0.1 t squared. So from this and from our knowledge of calculus, the differential of a constant, this is 0. So what we have left is this side of the equation, which will give us the differential of 0.1 t squared will just be equal to 2 times 0.1 times t to minus 1. Therefore, our acceleration function is equal to 0.2 t. So we have now both the velocity function 3.0 plus 0.1 t squared, and we have the acceleration function. Now, what if we are asked to find the average acceleration from a time interval? Let's say that let's say initial time or time 1, the average acceleration for the time interval 10 to 20 seconds. Let's say your time 1 is 10 seconds and your time 2 is 20 seconds. Now there are two ways for which we can solve the average acceleration given this time interval, 10 to 20 seconds. First, of course, we can solve it using our knowledge that average acceleration is delta Vx over delta t. Itong equation natin for average acceleration. If average acceleration, let's say ax is equal to delta Vx over delta t, therefore this is also equal to V2x minus V1x over time 2 minus time 1. This is now our equation for average acceleration. Now we already have the velocity function. Vx is 3.0 plus 0.1 t squared. If we will substitute 10 and 20 seconds in this equation, for time equal to 10 seconds, time 1, which is 10 seconds, your velocity, let's say this is v1x, is equal to, let's try to compute. We have the velocity function 3 plus 0.1 times 10 seconds squared This is 13 meters per second. 13 meters per second. For time 2, which is 20 seconds, we have v2x. Again, substituting 20 seconds to our velocity equation, we'll have, let's just replace this by 20 seconds. We'll have 43 meters per second. We'll have 43 meters per second. Now going back to our average acceleration equation, where v2x minus v1x over t2 minus t1 is equal to average acceleration. So we all now have the given. The average acceleration ax is equal to v2x 43 meters per second minus 13 meters per second all over time 2 20 seconds minus 10 seconds. So we'll have 43 minus 13 is 30 meters per second all over 20 minus 10 seconds. So the average acceleration is 3 meters per second squared. So this is the average acceleration. But there is another method to use that we can use to solve for the average acceleration using the acceleration function. So we have the acceleration function ax is equal to 0.2 t. Okay, so we will now use our knowledge in definite integral. So there will be a lower limit and an upper limit using with respect to time. Remember that our function is with respect to time. So we will limit our function with respect to the time interval, the lower limit and the upper limit time interval, which is 10 and 20 seconds. So if we will be using definite integral on this acceleration function, again we all know that acceleration is dvx over dt, or we can have this as 1 over dt times dvx. But dvx, if ax is dvx over dt, therefore dvx is ax dt. Just cross multiplying this equation for our acceleration, we will see that dvx is also equal to ax dt. So we will have this 1 over dt, then we have ax dt. Now how can we get now, because we have the acceleration function, but ax dt is dvx, therefore this is your change in velocity, no, wherein your change in velocity is needed to get your average acceleration, because again average acceleration is change in velocity. So this is also change in velocity, because again your dvx is equal to ax dt. This is change in velocity, ax dt. But we have the acceleration function, so we will get the antiderivative of this function of this term, or the antiderivative or the integral. So we will have now 1 over dt times the integral of ax dt. So we will have now the limit. The lower limit is 10 seconds to 20 seconds. So 1 over dt is your change in time. This is your delta t, which is also equal to 20 minus 10. We'll have that later. Times the integral of our acceleration function, in which our acceleration function is 0.2 t. Okay, we have 0.2 t dt. Again, from 10 to 20. So if we will solve this function, this will be 1 over delta t, change in time, 20 minus 10 is 1 over 10 times the integral of 0.2 t dt. This will become 0.2 t 1 plus, understood that there is an exponent 1, so this will become 1 plus 1 over 1 plus 1. So now our equation will become 1 over 10 times 0.2 over 2 t squared. But this is evaluated, this term. Actually, all this term will be evaluated from 10 to 20. This term will be evaluated from 10 to 20. The lower and the upper limit. Okay, so substituting our time to this equation, so we'll have now 1 over 10 times 0.2 divided by 2 is 0.1 t squared. Again, this all of this term will be evaluated 10 to 20, the limit. Then we will just have to subtract the value that we will get from substituting the upper limit minus the value that we will get in substituting the lower limit. So the upper limit is 20. So if we will substitute t, the upper limit 20 seconds, if we will substitute it to this variable t, the upper limit, let's say time is 20 seconds. Let's try to solve. So we'll have 1 over 10 times 0.1 times t squared, 20 seconds squared. So we have 4 at time 20 seconds. The value will be 4. So at time 20 seconds, acceleration, let's say acceleration 2 is 4 meters per second squared. And at time, let's say the lower, time 1, let's just say this is time 2. Ito time 1, then our time 1 is 10 seconds. Substituting 10 seconds to this equation, let's just substitute 10. We'll have 1. So let's say AX1 is 1 meter per second squared. Again, for us to get the average acceleration, we just need to subtract the value that we get from substituting the time for the upper limit minus the lower limit. So this will be 4 meters per second squared minus 1 meter per second squared. Acceleration, average acceleration is 3 meters per second squared. This is the same answer that we get using the first method that we used earlier, 3 meters per second squared. So that's how we solve for the average acceleration using our knowledge in calculus.